Hi there, this is our video on 100N condensate. This is on the steam generators, a continuation of condensate 2. The steam generators, there are 12 of them. They sat in the 6 cells in the 109 building. Basically you had a vessel with a 3-inch thick wall thickness, 10 foot 10 inches diameter, 57 feet long. On the top of this, you had 10 14-inch steam nozzles that went up to the 2 steam drums. These went up on the roof to the main steam header. Inside this, you had your tubes that the primary water went through. This is drawn wrong, just did it to show it. The primary and inlet and outlet lines actually come through this way, but this way is a little easier to draw. Primary water came in. This is called the transition piece. Went through the tubes, come back out, and returned back to the primary feed pump. The primary ran about 1556 psi. Inlet was around 543 degrees, outlet about 400 degrees. On this side, produced steam says about 135 psi. There's about 16,000 square feet of heat surface. Had 1,916 5/8-inch Inconel tubes. It weighed about 335,000 pounds. They went the pH 8.2 to 9.6, O2 less than 100 ppb, hydrazine greater than 10 ppb, and chlorides less than 500. The shell was supported, one end was fixed, and the other end was on a roller for expansion. Part of the internals of this vessel, you had your feed water nozzles or header. There were 4 of these total, 2 on each end. This is where the condensate 2 water would come in. I'd feed the bottom here and go up through the tube bundles. There's also another valve, 218 valve, for flooding the vessel with. The top part, you had your blowdown header, had like a continuous blowdown. This is usually where the solids will concentrate most in a steam generator or boiler. Down here you have your cleaner feed water coming in. Up here the steam's leaving the water, so this is the highest level of dissolved solids. You take a blowdown off this, off the BDV 211s, and there's also a bottom blow. There's a 211, different number. These went to the hot water quality lab, checking for tube leaks and chemistry. From here it went down to the BDV 212 and out the 10-inch blowdown header. On top of this, you had the deflector screens, and these are like a chevron screen that changed the steam direction rapidly and knock out moisture. Then you had a set of dryer screens on top of that. Then you had dry boxes up here for each of the outlets. On top of this, you had the water-to-water header for water-to-water cooling. During water-to-water operation, I believe it was filled to about 30 feet. I think the level transmitter went 0 to 45 feet. So this would be flooded with water. From here to go back to a dump condenser, selected, then come back in through the condensate pumps from condensate 1 to condensate 2 and fed back in. Here's the end view. Put out 0.25% moisture at full load. They won the water 2 7/16 inches above the center line. These are the 2 bundles. These would be the inlet reactor water coming in, and this is the outlet. Had your blowdown pipes. I believe they were 8 inches below the center line. Down here's your feed water lines. They had holes in them, so they'd spread the feed water out uniformly across the 2 bundles. I'd feed up through here. This would be your dryer deflector screens. These are the dryer screens, and that'd be the dry box. Okay, this is the shrink swell pressure-related diagram. These steam generators had uncompensated level, so it had to be compensated for the different loads where to carry the level at to maintain this 2 7/16 level. This is real common in all steam generators. You have your actual level, and then you have your indicated or uncompensated level on the sight glass. Inside the steam drum, you have steam bubbles inside the water mixture. This weight of this water is less than the water out here, so this is just a weight compensation. the weight here is equal to the weight here with the water with the steam bubbles in it. If you drop the boiler pressure, the bubbles will expand and you'll have a high level. Level here will come up, show a high level. And then as the pressure comes back up, the bubbles get compressed, all of a sudden the level drops like a rock. So a lot of feed water controllers will look at the steam flow and the feed water flow, and they'll change the feed water flow valve before the level changes. The level will be for biasing or correcting the actual level. So this is a major concern running these kind of pressure vessels. The level you see may not actually be what's going on inside. And a lot of times when you put a lot of feed water in a boiler, it drops the pressure, the level drops, and then all of a sudden you'll go the other way as the pressure comes back up. Now you got too much inventory in the drum. So they had a chart for compensating the level for these. We've included that in the end of this. And some other drawings of this stuff, actually some of the more the print drawings that makes more sense of this. This is kind of a quick overview of it. Okay, here's some of the steam generator design data. I won't read the whole thing through. We'll leave it up for a minute, or you can always look at it on the computer. They did weigh about 335,000 pounds, a little over 160 tons, which is pretty impressive. Shell thickness was about 3 inches thick. The tube sheet thickness was 5 1/8 inch. It's kind of a diagram of the water level, maximum permissive mixture level, minimum level. There was a chart, I believe, that was used to compensate for the level to the actual level inside the steam generator based on load. Here's some more design data on it. Now a diagram of the water flow. You had your 4 6-inch feed water nozzles. They fed the headers down the bottom. There's 2 on each end of the steam generator, then there's 2 on each side here. This shows the center line elevation. The bundle sat just a little bit above the center line. So the primary coolant be through the bundles. Up here are the deflector screens, these are the dryer screens. Another end view diagram. It shows the 2 bundles in here, 2 bundle supports, feed water lines, manway on the end of it. This would be the primary coolant inlet and outlet part of it. Just another diagram of how the flow went in it. Just more information on the tubes. Another diagram, the primary coolant side of it. Shows your tube. You have your feed water on both ends. It's 10 foot, 10 inches ID, 57 feet long. It's kind of more of a little better drawing of all the internals inside of it. That level transmitter across here, different dryer screens and deflector screens. Shows the 2 bundles and the 2 bundle supports. Shows kind of the basic layout of the cells. It's just the steam generator cells and kind of the basic layout of the primary coolant flow in the cell. The middle cell had all the graphite cooling stuff in it. This is about the only picture of the steam generator we have. Shows the primary coolant piping. You have a sight glass on the end. Your primary coolant pump sat back here. These are the steam outlet pipes, the steam collection drum, This would be a primary coolant, be a bypass line coming down the side. If anybody has any pictures of this, we'd appreciate it. This is about all that we have. Down here shows the pipe truss while they're building it. And that's about all we have on this.